In this video, we'll learn how to find the maximum or minimum of a quadratic function. When a quadratic function is given in a standard form, let's say fx equals to ax squared plus bx plus c, you can find its maximum or minimum value in two ways: by converting the function to vertex form or factored form. But before we even start, let's figure out if we are looking for a maximum or a minimum. That's actually super easy. You just need to look at the value of a, which is the coefficient of the x squared term. If a is positive, the parabola opens upwards and the vertex is the minimum point. If a is negative, the parabola opens downwards and the vertex is the maximum point. But you need to be careful here. The function must be in the standard form. If it's not, for instance, if you have a quadratic function fx equals to negative 5x squared plus 7x minus 8, you can't just say a is 5 because of the parenthesis. So what you need to do is to convert it to the standard form. You need to distribute the negative sign into the parenthesis and express it as a standard form, which is negative 5x squared minus 7x plus 8. So now you see a is actually negative 5. Now let's move on to our example to explore both methods for finding the vertex. In this case, we have the a equals to minus 3, so we know that the vertex will be a maximum. Now let's first try to find this maximum by converting the function into the vertex form, which can be expressed as fx equals to ax minus h squared plus k. It's called vertex form because the h and k are exactly the coordinates of the vertex, which are what we are solving for. So how can we convert this standard form to this vertex form? Well, you see there's a perfect square in this vertex form. Let's see what we can get if we expand it. So we have fx equals to ax squared minus 2hx plus h squared plus k. So our task is to manipulate the first two terms of our function to make it look like this part in this vertex form. And we'll leave this 15 alone for now, which will eventually be part of this k value. So first, let's factor out the negative 3 from these two terms. So we have fx equals to negative 3 x squared. So negative 12 divided by negative 3 will be 4x, then plus 15. So by factoring out the negative 3, you see the x squared term has a coefficient of 1, which is what we need for a perfect square. And if you compare this expanded vertex form, we can see that a is negative 3. And if you look at the coefficient of x, negative 2h must equal to 4. So we have negative 2h equals to 4. So we know h is negative 2. To create a perfect square, we also need this third term, h squared. Since we found h is negative 2, then we know h squared is negative 2 squared, which is 4. So we can add it to our equation to make a perfect square. Negative 3x squared plus 4x, we can plus 4, then plus 15. We added this 4 artificially. Well, we can't just add this inside the parentheses without changing the function. To keep this equation balanced, we must also subtract 4. But don't worry about this negative 4. We can pull it out of the parentheses. Let's separate this negative 4 from the perfect square trinomial we've just created. It will make it look more straightforward if we write it as this: minus 3x squared plus 4x plus 4 minus 4 plus 15. Now I can pull this negative 4 out of the big bracket by multiplying it by negative 3, right? So we have negative 3 multiplied by this trinomial x squared plus 4x plus 4. Then negative 3 times negative 4 is positive 12. Then plus 15. Then we have negative 3 multiplied by this perfect square trinomial. Then 12 plus 15 is 27. Now you see we've successfully created the trinomial for a perfect square. Again, if you compare this to our target, this is a, which is negative 3. We need negative 2h here as the coefficient of x because h is negative 2. Then we have 4x, then h squared is 4, and k is 27. Then we can convert this trinomial back into its squared form, which is negative 3x plus 2 squared plus 27. So now we have turned the standard form into this vertex form. The vertex of the parabola is at h and k. So in our case, h is negative 2 and k is 27. Right? So negative 2 and 27 are the coordinates of the vertex, which means the maximum value is 27 and it occurs at x equals to negative 2. All right, now let's try to find the maximum using another method, which is by converting the standard form into the factored form, which can be expressed as fx equals to a multiplied by x minus r and multiplied by another factor x minus p. When factoring a quadratic function, the first step is to find if there's a common factor. In our function, we can see that negative 3 is the common factor. So let's factor it out. We'll get fx equals to negative 3 x squared, and negative 12x divided by negative 3 is 4x. 15 divided by negative 3 is negative 5. Next, we need to factor this quadratic expression inside the bracket. The coefficient of the x squared term is 1, so we can factor this as minus 3 times x plus something, then multiplied by x plus another number. We need to find these two numbers that add up to 4 and multiply to negative 5. It's straightforward to find those two numbers are actually 5 and negative 1. So we have our factored form as negative 3 x plus 5 and x minus 1. Once we have the factored form, we can find the zeros of the function, which are the values of x that makes fx equals to 0. We need to determine the values of x that makes the fx 0. We know that when x plus 5 is 0, fx will be 0. This gives us the first 0, which is x equals to negative 5. In the other case, when x minus 1 is 0, fx will also be 0, which means our second 0 is x equals to 1. So minus 5 and 1 are the two zeros of this quadratic function. If we were to plot this function, one 0 is negative 5 and the other is at 1. Since our function has a negative leading coefficient, negative 3, we know the parabola opens downwards and it will cause these two zeros. To find the coordinate of this vertex, we know it lies on the axis of symmetry of this parabola. The axis of symmetry is exactly in the middle of these two zeros. So for the x coordinate of this vertex, it will be the average of the two zeros, negative 5 plus 1 over 2, which is negative 2. Now to find the y coordinate, we just need to find the value of the function or the value of y when x is negative 2. So y is f negative 2, it equals to negative 3 multiplied by negative 2 squared minus 12 multiplied by negative 2, then plus 15. So it equals to negative 3 multiplied by 4 plus 24 plus 15, which is 27. So now you see the coordinate of the vertex is negative 2, 27. This is exactly the same result we got using the first method.